graph of the sine function. The sine function is y equals sine of x, or using function notation from algebra, f of x equals sine of x. If I want to draw a graph of this function in the xy plane, I should start by making a table. Now you probably remember from algebra making a table by starting with x equals 0, 1, 2, 3. That is not going to be a good idea here. Those are not values that I can easily evaluate in the sine function. The easiest numbers to use for x would be the numbers that go with the quadrantal angles. And that's because the sine function sends me out the b coordinate of the point where I land on the unit circle. So I want to use quadrantal numbers for x. 0 would be great, followed by pi over 2 up at the top of the circle, pi, 3 pi over 2 down at the bottom, and 2 pi. Now I just need to fill in the sine ratio, or the b coordinate at each spot. When x is 0, my b coordinate is 0. When x is pi over 2, in other words, I've rotated pi over 2 radians, my b coordinate is 1. After rotating pi, my b coordinate is back to 0. If I rotate down to 3 pi over 2, my b coordinate is now negative 1. And of course, rotating all the way back to 2 pi, I'm back to a b coordinate of 0. Now that I have a table of values, I can start drawing my graph. Once again, from algebra, you are probably used to marking some scale on your axes and labeling them 1, 2, 3, 4. For trig graphs, that's just not helpful. Based on my table, I need to count by 1/2 pi. So pi over 2, followed by pi, then 1.5 pi, or 3 pi over 2, and then 2 pi. We're counting by half pi units. The y-axis, well, it looks like the highest value I've got is 1. That's pretty clear. There is no way to get a coordinate higher than 1 on the unit circle. So I've got 1 at the top and negative 1 here at the bottom. Okay, let's start plotting points and connecting the dots. We start at 0, 0. From there, the b coordinate rises so that at pi over 2, you've reached a b coordinate of 1. Of course, then it starts falling so that by pi, you're back to 0. At 3 pi over 2, your b coordinate is down at negative 1. And then by 2 pi, you're back to 0. Well, I've just drawn a portion of the sine function. Now, what happens after 2 pi? What if I rotate around farther than 2 pi? Well, you know exactly what's going to happen. You're just going to repeat all the same values. Here I am at 2.5 pi. 2.5 pi is 5 pi over 2, and I'm back up at 1 again. The same thing is just going to repeat over and over and over and over as I go around. How about if I rotated around in a negative direction? Well, let's say I went negative pi over 2. Negative pi over 2 would be right over here, and obviously I'm down at negative 1 for my b coordinate, which means the graph continues in that same pattern in this direction as well. We call the sine function a periodic function because it repeats itself over and over and over. Let's talk now about some features of the sine graph. Here's a nicer copy of the graph. You can see we're still counting by 1/2 pi's here. On the y-axis, we appear to be counting by 0.5 now, 0.5 and then 1, negative 0.5, negative 1. What is the domain of this function? Domain just means what are all the possible x's that could ever go into this function? Well, we've already said that this thing continues in both directions indefinitely, which means every single x eventually will get used. And so we say the domain is all real numbers. You can stick anything you want into this function. Or writing it in interval notation, we say the domain is the interval negative infinity to positive infinity. Everything, all numbers. How about the range? The range refers to all the possible y values that may ever come out of this function. Is the range all real numbers also? Not at all. You can see that the highest y value that ever shows up on this graph is 1, and the lowest value is negative 1. So we write, in inequality notation, y is between negative 1 and positive 1. Or in interval notation, the interval from negative 1 to 1, the brackets indicate, of course, that we include those endpoints. What's the period of this function? The period refers to the minimum horizontal distance before the graph starts to repeat. In other words, I'm starting right here. How far horizontally do I have to travel before that same pattern repeats? And maybe it's tempting to say, oh look, when I get to pi, I'm back at 0 again. Yeah, but the same pattern isn't repeating. I'm going down here. I was going up at the beginning. I have to travel enough until I'm back at 0 and moving in that upward direction. Well, that doesn't happen until here, right? Starting here, I would repeat that same shape over and over and over. So we say the period is 2 pi. What about symmetry? Well, we call this function an odd function, which means it's symmetrical across the origin. You say, what does that mean? Well, it essentially means that if you rotate the picture 180 degrees, if you turn it upside down, it will land on itself. It will be the same exact shape that you started with. That's an odd function. Another way you can say that is if you flip the picture across the y-axis and then flip it across the x-axis, again, the picture will land on itself. Let's go to the midline. The midline is the horizontal line that cuts the graph in half. And I don't think it's very difficult to see that in this picture, that would be the x-axis. Remember, horizontal lines always have the equation y equals a number. In this case, that number would, of course, be 0. So the midline is the equation y equals 0, which is, of course, the x-axis. The amplitude refers to the vertical distance from the midline to the top of the graph or to the bottom of the graph. And you can see here that that distance is clearly 1. So the amplitude is 1. And then we come to the 5 key points. The 5 key points are the points that we started with from that table that we made. The 5 key points are the points that either hit the midline or the high or the low spot within one period. So we can write down those coordinates easily. 0, 0, pi over 2, comma 1, pi 0, 3 pi over 2, negative 1, and 2 pi, comma 0. One thing to pay attention to here is that on the sine function, the 5 key points go middle, high, middle, low, middle. Middle, high, middle, low, middle. Obviously, you want to absorb as much of this information as you can over time. But for now, when you hear sine function, here's the picture at a minimum that should be emblazoned in your brain. That shape, knowing that it ends down here at 2 pi, you can always get the rest, knowing that this period spot is 2 pi, knowing that the height here is 1. I like to call this the hill and the valley. You can come up with your own name, but know that the sine function is the hill and valley, ending there at 2 pi, going up as high as 1. Thanks for watching.